Okay, problem number 5. I see secant squared minus 1 and secant. Well, secant squared minus 1 reminds me of a Pythagorean. Remember, if there's ever a squared and a 1, that's probably a Pythagorean. So in case you don't remember, let's go ahead and create our own identity. With sine squared plus cosine squared is equal to 1. We divide by cosine because secant is 1 over cosine on the bottom. And tangent squared plus 1 equals secant squared. That's the one we want to use. And if you notice, if I move the 1 over, that's a secant squared minus 1 that we wanted. And that all changes out for a simple tangent squared. Okay, so now I see I need to try to get this to become sine. So let's go and write our identities for tangent and secant. Tangent is sine over cosine, our quotient identity, all over 1 over cosine, which is our reciprocal identity. And we're gonna, since we're dividing by fractions, we can now multiply by the reciprocal. All right, multiply by the reciprocal. And you'll notice that the cosines will divide out. And we're left with sine squared. Looking at our next problem now, again, we have a tangent, and we want to make that maybe into 1 minus cosine. Well, that's going to take our Pythagorean identity again, because I see a 1 plus secant on the bottom, and I'm probably going to end up dividing that out. So now that we have our tangent identity out, we're going to try to solve for tangent by itself. So as you can see, we're going to end up subtracting by 1, leaving tangent squared by itself. If you notice, the secant squared minus 1 is actually what we call a square, a difference of two squares. And we're going to go ahead and factor that out and split them into 2 once I rewrite this. And this is the trick, seeing that if I factor that out, we'll be able to divide out the 1 plus secant theta. How to get better at these problems? You really have to just keep practicing these identities and knowing how to do this by just doing this over and over and over and seeing there's only a couple of tricks of using Pythagorean and factoring. And in this case, as you can see, the secant theta plus 1, they divide out, and we're left with secant minus 1. Now, secant minus 1 doesn't look like the 1 minus cosine over cosine, but can I make secant into a cosine? Sure I can. It's just the reciprocal identity, 1 over cosine. So we're going to multiply cosine on the right side to get a common denominator. And if you notice, that's my 1 minus cosine on top, which is our goal, over cosine. And now we're done. Okay, I'm seeing a cotangent of pi over 2 minus theta. We mentioned these are our cofunction identities. So that automatically becomes a co-buddy of tangent is tangent. And tangent and cosecant, let's see if we can rewrite this in its native form of sine and cosines. Tangent sine over cosine. Cosecant is 1 over sine. And then I see something that's going to divide it, the sine. Once those divide out, we are left with 1 over cosine on the bottom, which is a reciprocal identity, and we're left with secant again. We're done, once again.